Okay, so now this is just like the rocket competition. We want the rocket to go this far. This is our launch velocity, and then we've got to figure out the launch angle. Okay, now the launch angle is going to be the inverse sine, so you have to go second sine, right, of gravity times the range. Here, I'm going to put a little times there, times the range, okay, divided by the launch velocity squared, right, and then that whole thing divided by 2. Okay, that will give us our angle, okay? And then whatever angle we get, that angle works, right? And then also 90 minus that angle works. So for example, let's say I got 10 degrees as my angle. 80 degrees would also hit it. If 20 degrees hit it, 70 degrees would also hit the thing, right? So that's what we're going to put in here is the low angle and the high angle that would hit it. Okay, so let's look at this guy here, right? We want it to go 45.7 meters. We've got a range of 24 meters, or a velocity of 24 meters per second. And so I'm going to go inverse sine of 9.8, which is g, right, times the range, which is 45.7. And then I'm going to divide by 24 squared. So square that. Don't forget to square that, right? And then that's twice the angle, so we got to divide by 2. Let's see what we get. So second sine. Bless you. All right. Inverse sine of 9.8 times 45.7 divided by 24 squared is equal to, and then I'm going to divide that by 2. I'm getting 25.517. So I guess I'll say 25.5 degrees, and then I'm going to go 90 minus the answer. So 90 minus second answer, 64.5 degrees also works. What did the 64.5 degree angle say to the 25.5 degree angle? Thank you. Get it? See, they're complementary. So that double re was 90 minus 25.5 gives you 64.5. That's a smiley face. Okay, so let's see. Let's look at this guy. We want it to go 9 meters. It's going 13 meters per second, right? So I'm going to go inverse sine. So second sine, hit the second button and sine, right? G times the range, so 9.8 times the range is 9, right? Divided by 13 squared. Divide that by 2. Right? So don't forget the parenthesis. You got to go parenthesis divided by 2. Okay, so here we go. Second sine of 9.8 times 9 divided by 13 squared, and then divide, right parenthesis, divided by 2. I get 15.7 degrees, right? And then I'm going to go 90, so that equals 15.729 or something like that, right? And then 90 minus 15.7. So I'm going to go 90 minus second answer, 74.3. Right? Either one of those things would hit the target. Okay, and then we'll get down to this guy here, right? So 12 meters per second, the range is 200 meters, right? This is not very fast, and that is really, really far. So I just don't think this is going to work, right? So let's just try it, though. Inverse sine of 9.8 times the range, which is 200, right? Well, 9.8 times 200 is roughly 2,000, right? Okay, divided by 12 squared. Well, 12 squared is 144. 2,000 divided by 144 is a number bigger than 1. I think we can all agree, right? And the crazy thing is you can't take the inverse sine of a number bigger than 1. So my calculator is going to blow up. Okay, watch this. So I go second sine 9.8 times 200 divided by 12 squared, and then divided by 2. And my calculator says, it gives me, actually, this is a TI-86, so it's giving me very strange like coordinates or something like that, which I deeply don't understand because I'm not the best mathematician. Okay, so basically your TI-84s are going to say domain error. Okay, Domain means those are the numbers you can put in there, and we put a number in there bigger than 1. This thing here is bigger than 1. Wait, yes. Okay, and you can't find the inverse sine of something bigger than 1. What that means is that there's no angle at which we can launch this to reach 200 meters. It just can't go that far, even at 45 degrees, right? So the answer to this is lemon, and then lime is the, right? Or any two complementary things, right? You could say purple and black as well, you know, or crimson and white, right? So there you go, equally correct. It's too far away. Now, if you want to know what the maximum range for something is, right, you can actually just go, because remember the range is equal to v squared over g sine of 2 theta. Well, if you put 45 degrees in there, that's the best angle to launch it at. Sine of twice 45 is just 1. So the range is just v squared over g. So in this thing, the maximum range is 12 squared divided by 9.8. The farthest this could go is 14.7 meters. Okay, so yeah. It won't go 200 meters. That's the trick here, right?